Hi, I'm going to be discussing ionization energy. And so the definition for that is the energy required to remove the first valence electron from an atom. The atom would be in the gas phase if you want to put that in parentheses. So the first question is, what is holding an atom to the electron? Or what is holding the electron to the atom? Either one. Coulombic force is the answer. And what Coulombic force does is it pulls the valence electrons into the nucleus. And basically what ionization energy, how that fits in, is it is the energy that is needed to overcome that Coulombic force. So if a valence electron is tightly held, there is a high Coulombic force, and then if it's loosely held, there is a low Coulombic force. So if there is a high Coulombic force, a high amount of ionization energy would be needed to overcome that. And then same thing, if there isn't a lot of Coulombic force, then you wouldn't need as much ionization energy. So basically what I'll be discussing is the periodic trends for the ionization energy. If you go down a group or down from the green to the gray vertically, the trend would be that ionization energy decreases. And the reason for this is because as you go down the group, the number of valence electrons in a higher energy level, because the energy level that the valence electrons are in are equal to the row number. So like for instance, if you follow the mouse, that row 1 would be there, and that would be in the valence electrons would be in the first energy level. Row 2 is here, and it would be in the second energy level. 3, third energy level, and etc. all the way down. So if the valence electrons are in a higher energy level, the Coulombic force is less because they are less. The electrons are not held as tightly together. So if the Coulombic force is less, then therefore the amount of ionization energy needed to remove that energy is less. And then if you move across a period, so from like this gray area all the way over to the yellow, left to right, the trend would be that ionization energy increases. And the reason for this is because as you go left to right, the nuclear charge increases. So there's a higher pull towards the nucleus, and therefore you would have a higher Coulombic force. And as I said earlier, if there's a higher Coulombic force, then that total ionization energy needed would be higher as well. Okay, so with these two trends, down a group and across a group for ionization energy, there are two exceptions, and that is between BE, which is right where the mouse is, that purple with the 4 in the corner, and then the orange 5, which is B. So those two are beryllium and boron. And as you already know from the previous unit, Be, beryllium, would be in the S block, but then boron is in the P block. And the P block is slightly further away from the nucleus. So the change in distance causes the ionization energy to decrease because it is slightly further from the nucleus. So instead of going across the period, the ionization energy typically would increase, but for this exception, the ionization decreases because the further distance from the nucleus, the less energy needed to overcome. So that's the first exception. And then the second one would be between this orange 7 and this orange 8. That would be nitrogen and oxygen. Like I said before, the typical trend would be that ionization energy increases. But here, the ionization in fact decreases. This is because of the electron-electron repulsion in the orbital. So the valence electron is slightly further from the nucleus for O, 8, than it is for N. And if it is further distance away, there's less energy, and therefore less energy is needed to overcome it. So that is all. Thank you.